Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 3 of the Murach MySQL book, second edition. And Chapter 3 is called How to Retrieve Data from a Single Table. And there are slides that come with the chapter, and I'm going to go through those and comment on those. I also want to encourage you when you're going through the chapter on your own, or when we're going through the slides, to feel free to retrieve the examples from the book and to run them. Now, how would we do that? Well, let's take a peek ahead at an early example. Okay, so an early example, the first one, a simple select asterisk, that's all columns from the table invoices. Okay, now how would you find that if you wanted to run it? Okay, all right, let's go do that. So I'm going to go down and open up my MySQL workbench, on which, my virtual machine here, I've already installed MySQL Community Edition and MySQL Workbench on Windows 7, and I've done a couple of tutorials that you've probably already seen. So I'm going to open up a connection, and now I'm going to go find the material from the book that's associated with the chapters. So I'm going to go up here to the toolbar line and click on the second one that opens an SQL script. And I'm going to find my way to, on Windows, we install the material from the book under Computer, and then we're going to open local disk C, and if we follow the instructions, we should have a directory on C called Murach and a subdirectory called MySQL, and then we should have a subdirectory yet again of book scripts. And we're on chapter 3, so we open up chapter 3, and we've got 302, 304, 305. So let's look at 302. And interestingly enough, it looks like we have an example from later in the chapter, something that's a little more challenging. So how would you run these? Well, the way that he's put them into the files, he's got more than one query in the same file. So I think the best way to do it is to find the one that you want. Well, let's take this third one, okay? And first of all, you have to remember that he hasn't put a use with the name of the database. So we're going to have to make sure that we connect to the database that's used in the textbook, and that's typically AP. So right now, that's the one that I'm on, but let's assume that I was not on any, or I was on EX. Well, you can tell the one that you're on over here in the panel to the left because it's the bolded one. So let's go to AP and double click on it, and now I'm using the AP database. And if I wanted to take the third of these selects, I could highlight it and then use the left lightning arrow, which says to execute the selected portion of the script. So we'd run that and we'd get the answer. Okay, so at any point in my lecture or when you're reading through the chapter, if you go, well, I'm not really sure what that would look like. I mean, how would that work? It's really helpful to me to take a pause, go find the example code, run it, and then even do things to it. Even say, well, what if I change this value to this, or what if I change this value to that? So this can be a very experiential way of learning. Now, I'm not going to do a lot of this while I'm doing the lecture, but it's something that you could put me on the pause and you could go do that. Or you could do the same thing when you're reading through the chapters. Okay? So, let us go back to the slides and get going. So, how to retrieve data from a single table. This is important to us because we're going to be learning about the select statement, which is really the workhorse in SQL. People are primarily interested in answers from their IT, not questions. Although somebody who is perhaps well-versed in data analytics might say that we're looking for answers that are questions. But let's not go that far. So we want to learn how to use the select. Typically, we're going to be selecting and retrieving data from more than one table at one time. And the reason that we do that is relational databases are designed to separate the data associated with each entity, each thing in our problem space into a separate table. So in the AP database, for instance, we have, let's just take a look. Here are the tables that we have. General ledger accounts, invoice archive, invoice line item, invoices, terms, vendor contacts, vendors. Okay, so it's really separated out. Okay, and it's going to take some getting used to that in order to answer a question that you have about your application, that you're going to have to figure out what tables hold the answers, and you're going to have to learn about how to join them into a query that uses more than one table. Well, we're not doing that in Chapter 3. It's always good to start out modest. So even though we typically won't be doing queries that only use a single table, we're going to start with that. Okay? So let's go back to the slides again. We've got learning objectives, which I will leave for you to read on your own. And what we're really covering in the chapter is the select. Okay, so the select is a part of SQL. It's part of the DML, the data management language, and it's the most popular of the statements. Again, because people are basically looking for answers from their IT, and when they're getting them, they're using the select. Okay? And here are the parts. You see the syntax up on the top part of the slide. And we can see that there are 5 clauses that make up the select statement. The select clause, the from clause, the where clause, the order by clause, and the limit clause. And we're going to learn about them kind of one at a time. So a really simple select is what we see here on slide 5. Select, and then we have an asterisk which says all columns. So we want to see all columns from, then the name of the table, invoices. Okay, and implicit is that because we haven't said anything about how to limit the rows, we're going to see all columns and all rows from the invoices table. And what we're seeing here is just a little bit of the result set that you would see appearing in your MySQL workbench. Okay, so you'll notice that there's a little comment under the bottom left, 114 rows. So even though we're only looking at 3 rows, 114 were generated. So there are 114 rows in the invoices table. Okay, and you see the columns here, and that there is a horizontal scroll bar. So I don't think that we're on the last of the columns. So we're not seeing either all the rows or all the columns. Okay? Now, here is a more realistic select for that same table. Instead of saying in the select clause, select asterisk, we're going to give a list of the names of the columns that we want. Invoice number, invoice date, invoice total, okay, from invoices, and we're going to say order by, invoice total, and then desk descending. Okay, so let's think about how those things operate. Well, your alternative to asking for all of the columns with an asterisk is to ask for individual columns by name. And the way that we do that is that we name them and we put commas between the names of the columns. There's no comma after the last one that you want. So we have invoice date, comma, invoice total, but after invoice total, there's no comma. And we go right into the from clause, from invoices, the name of our table. It only lists one table because we're only dealing with one table. And the order by is important. Now, in this case, we are naming one of the columns that is in our column list. It's in the select clause, okay? And we're saying that we want to order by that, and the default, when you have an order by clause, is that you want to sort the rows in ascending order. So if you don't want them in ascending order, if you want them in descending order, then you need to say that explicitly. So DESC is descending, okay? There is an ASC for ascending, but that's the default anyway, and we don't really have to do it. Well, why are we saying that we want to order these a certain way? Well, it's the nature of relational tables that the rows are not ordered. The columns appear in a particular order, although it's not significant. So when you say you want to list out all your columns, you'll typically get them coming out in the same order, although it's not really significant. The rows will often be listed in the same order, and in fact with the versions of MySQL that we get that we're using, they typically do come out in the same order, but it's not part of the definition of a relational database. So the definition of the relational database says the order of the rows is undetermined, okay? And in some products, it is so undetermined that if you run a select without an order by, and then you run it again, it won't come out in the same order. And if you run it a third time, it'll come out in some third order. So it's really going to be important for us to include an order by clause. And the descending is just our way of controlling what order it comes in. And we're going to see that we can order by a combination of fields. Okay. Now, in the select clause, it's possible to not only name a field, but to get a column to come back in our result set that is calculated. So here on slide 7, we're including two columns that are being taken as they are, invoice ID and invoice total. But then we're creating a third one. It's credit total plus payment total. And then we are able to assign it a name. Of course, it doesn't have a name because it's not really in the table. We're creating it with our query, and we're going to call it total credits. And we say from invoices, and now we have a where. The where allows us to limit the rows that we're going to get. This is pretty helpful because of the following thing. We would like the database management system, the server in particular, to do all the work. So what we would like to be able to do is formulate the question that we have exactly and get exactly the answer we want back. Now we could formulate the question roughly, get a lot of data back, and then have to search through it. But why do that? Okay, the server is very good at limiting the answer set to exactly what we want. So in this case, we decided we wanted only a single row, and we identified that by saying where invoice ID equals 17. And so we got back the 2 columns literally from the table. We got back a third one that was created for us from a mathematical expression. And then we got back only the row that we asked for, because when you say something like invoice ID equals a particular amount, and it turns out that invoice ID is a unique column, then you're only going to get one row. Okay, here's one that's pretty useful. One of the types that we have for data in SQL is a date, okay? And so what we're doing here is that we're trying to compare dates. So we're asking for 3 columns: invoice number, invoice date, invoice total, from invoices again, where invoice date is between, and then we have 2 dates, 2014-06-01 and 2014-06-30. Okay. And I just want to point out that we say that it's between these two and it's inclusive. If you look at what came out in the answer set, we have a row that is 2014-06-01. Okay? So it doesn't have to be greater than that. It's including the endpoints. Okay? And then we have an order by as well. Now, one of the things I haven't emphasized a lot, but if we back up the slide, if you look at the result sets that we're getting back from our queries, they're tables. Okay, they've got rows and columns. Okay, and it's the nature of relational databases that our selects return result sets that are tables in their own right. So here on slide 8, we see that we've got a result set that has 3 columns, and we're only looking at 3 rows, but there are 37 in the answer set. Okay? It's possible, as in this select statement on slide 9, it's possible that what we asked for is so restrictive that no rows qualify. Okay? So it's not possible to ask for no columns. Okay? So we do have to ask for either all the columns or some subset. So here we've asked for 3 columns from invoices where invoice total is greater than 50,000. And none of the rows qualify, so we get no rows in the table. So we essentially have an empty table. Okay? So that's what happens when you make a query that's very restrictive. Now that could be what we want to know. I mean, we might want to know, do we have any invoices over 50,000? And we find out that we don't have any. That's, it's probably happy information for us. So there's no failure in the result here, but the result is an empty result table. Okay, so there are some more features of the select statement that we want to go explore that give you some more functionality. Okay, so immediately after the word select, we can say all, or we can say distinct. Okay. And this is going to, oddly enough, this is going to limit the number of rows that we get back. So we're going to say we want to select all the rows that match or only the distinct rows that match, and then we'll get into the details of that. And these column specifications are either the name of a column or some kind of expression that can be turned into a column. And of course, we saw one where we did an addition and we created a column like that. So we can ask for all columns in a base table. A base table is the table that you're basing the query on. A column name in a base table, a calculation, or we can use a function. Now we haven't seen a function yet. We'll get to that. They're pretty powerful and you're going to like them. So column specifications that use base table values. So here's a basic one here. Select asterisk all of the columns. Select and then a list of the column names. Okay, we've used those already. We know how they work. Column specifications that use calculated values. Okay, so the first thing that we want is invoice total minus payment total minus credit total as balance due. So that says we want one column in the results set called balance due, and we give the calculation of that uses 3 columns that are in the table in order to produce the one column of calculated output that we want for balance due. The second example on the slide is a function. Now, if you've got programming experience, you'll recognize kind of the syntax that we use here as a function. So we say that we want to concatenate. So this function concatenates character strings. So the column first name contains a character string. The column last name contains a character string. And then we are concatenating in the middle. Concatenate is to kind of glom onto. We're combining first name, a space, last name, and that's going to create a column that we're going to call full name. So this concat is particularly useful for things like reassembling a full name from its component parts, which is a thing that we do in relational database queries all the time. Here's a select that renames the columns in a result set. So we had seen that we could use the as option to name a column that we were creating from a calculation. Well, you can use as on any column, and a common use for it is to give it a prettier column title than the proper column name. So here we've used invoice number spelled out, date and total. Again, these aren't the names of the columns, but there are times when people would like the query to be a pretty useful user report in its own right. These are maybe people who are using SQL directly as kind of a power user. For programmers who are going to get some kind of result set back, and they're going to pick through it and put the results into, say, a web page, this is less important of a feature. Okay. Here's a select statement that doesn't name a calculated column. So we have a fourth column here, and we show a formula for it. And if we don't use an as option, then MySQL is just going to name the column according to the formula that we gave it. Because it really doesn't have any other kind of reasonable name to give it. So if you don't use an as on calculation, you're going to see the formula in the name of the, you're going to see it in the column heading of the result set. So how are we going to do this math? Okay. Now, why are we doing math? Well, let's just go back. We just had a calculation. We had one here that used subtraction. We've had ones in previous slides that used addition, right? So what are the rules for the way that you formulate these expressions? Well, you can use the plus for addition. You can use the minus for subtraction. Those of you who've already worked with programming languages will not be surprised that the asterisk is used for multiplication. The slash is used for division. Two things that are not as commonly known to non-programmer types is if you want to do integer division, which means that you want to get the result without the remainder with no fractions, you can use div, div. And if you want to get the remainder, which is sometimes called modulo or the modulus, you use the percent or you use mod. Now, over on the right of the slide, we have order of precedence. This answers the question, how would we decide what the author meant if they did not provide enough parentheses to make the statement unambiguous? Now, if you work on my team, you never have this problem, because if somebody writes a statement without all the parentheses, you need to understand the order in which the operations are going to be done in the expression, well, then you're going to have hell to pay. I often say that I'm coming to your house with a baseball bat and I'm going to break your legs. Okay, but there are rules that say in the absence of parentheses, we do some operations before others. Okay, and that's called the order of precedence. So some of these operators are considered stronger. So multiplication, division, integer division, and modulo are the strongest. Addition and subtraction are the weakest. So we do the strongest before the weakest, and if things have equal strengths, we do the one on the left before the one on the right. Well, you may see a lot of slides or commentary in the text that explains, it'll give you some big ambiguous calculation without appropriate parens, and then it'll say, in what order is this going to be done? And I think the smarter answer is, well, first I'm going to the house of whoever wrote this, and I'm going to hurt them. And then I'm going to come back and figure out the order of precedence. Okay, so this is something I don't want you to have to know, but if some fool left you an expression that's not proper in terms of its use of parentheses, then you're probably going to have to know you do the strong operators before the weak operators, and if you have equal strength, you do the one on the left before the one on the right. Okay. Here's a select statement that calculates the balance due. Okay, so pretty straightforward. Okay, and because we're just using subtraction, we don't have to worry about the order because of the commutative rule. We can use parentheses to control the sequence of operations. So you can see how the second line of the query we have here on slide 17, the second line doesn't have enough parentheses for you to know which is going to be done first, but the third line does. Okay. So write your code to emulate the third line in terms of how many parentheses you use, but know, like in the second line, if there are not enough parentheses there, that the multiplication between the 7 and the 3 is stronger than the addition between invoice ID and 7. So we're going to do the multiplication first, and then we're going to add the invoice ID, which is kind of a goofy thing to do anyway, but this is just a toy example. The div and the modulo operators. Okay, so we have invoice ID divided by 3 as decimal quotient. So if we use the slash, we're going to get a real number as a result, a whole number plus a fraction. So decimal quotient, as you see, has got values to the right of the decimal point. When we use the div in the next line, we don't get any values to the right of the decimal point, so we have thrown away the remainder. But if we want to get the remainder, then we use the percent or the mod we could have used instead to get the remainder. And there are times when you want to do this integer division. There are times when you want to know, for instance, how many pages of 24 lines am I going to have, and how many lines are going to be on the last page. Okay, so those kinds of things lend themselves to that kind of math. So what determines the sequence of operation? Let's hope it's the latter of things here, the parentheses, but again, if your teammates have done you wrong, you perhaps have been left with an expression in which you have to remember the order of precedence. Now the concat function. Now, so I can't emphasize enough how there's a style to how we store data in relational tables. And one of the things that we do is that we try to break the data up into as atomic, as broken down as the fields can be, to give us the opportunity to reassemble them in just the way that we want. So for instance, if we have an address that includes city and state, we don't want to have in the database city and state, even though if maybe on an address line, we might want to print city, comma, state, space, zip code. What we want to do is in the query, we want to assemble the text as we want it in the answer, but we want to use the components that are well identified in the tables. So Concat is a really good thing for this. Here we've decided that we're going to just combine the vendor, city, and state with no intervening comma or space. Now this isn't something you would do, we just want to show you how it works. So we use this to combine city, state, and zip for that line of the address. We use this a lot of times to take the components of a name and to create a conventionally printed full name. How to format string data using literal values. Okay, so here you can see that we've used Concat, and it turns out that Concat is a really nice function because it can take a variable number of parameters or arguments. So in the previous example on slide number 21, we just had two, vendor city and vendor state. Here we have added in these literal expressions, these characters that are inside of quotes, or in this case we've decided to put them into single quotes or apostrophes. And so we're combining vendor city, comma, space, vendor state, space, vendor zip code as address. And if you look at the address, it's coming out as it maybe would be printed on the third line of the address in a letter. Pretty cool, huh? So the style of relational databases is this. Do a design where you break up the fields in such an atomic way as you can identify the components. And then to the extent that you want them combined in the output, use functions like concat to constitute the format that you want. Okay? That means that we can get the output in various formats depending upon the requirements at hand at the time. Now, you can, in SQL, you can have your quote marks be either double quote marks or they can be apostrophes. And it doesn't really matter which you use. How are you going to represent a quote mark or an apostrophe? Sometimes that gets hard to do. Okay? So here's how we do it. So we're going to have vendor name, and then we want to have apostrophe S. So to get an apostrophe S, we have to code 3 apostrophes in a row. On the other hand, it might be possible for us to just have put a single apostrophe inside of double quote marks, and that would have gotten the job done as well. Okay? So, terms to know, function. Well, the function we've learned so far is concat, which is really gets a lot of use. A parameter is one of the column names or other expressions, the column names, the literals, or other expressions that we put inside of the parentheses in a functional expression. An argument is another use for the same thing. In some programming languages, if we back up here, in some programming languages, it's called an argument when you use it, and then as the function consumes it, it refers to it as a parameter. But you more or less can use the terms argument and parameter to mean the same thing. And so, for instance, in this first concat, we've got, well, let's go to this, the second line because it's a little bit easier to see. Vendor city is the first argument or parameter. Comma space is the second argument or parameter. vendor state is the third argument or parameter, space is the fourth argument or parameter, vendor zip code is the fifth argument or parameter. Okay? That's how that works. And concatenate is a fancy IT word for pasting one thing to the end of the next. So if you concatenate columns A and B, you get NAB. If you concatenate A and B and C, you get NABC. And we typically use this word when we're talking about character strings. Okay, so we have some other functions that allow us to do some of this character string magic that gives us just the output that we want. So for instance, there are times when we just want the left portion of a character string. So there's actually a function named left. So the first argument or parameter that it gets is a string of some kind. Now it could be the name of a column, it could be some literal string, it could be some expression that's a combination of columns, whatever. It has to be something that in the end turns out to be a character string. And the number of characters is the number that we want. Okay, so here we're saying that we want to create a character string by a concat of the left first character of the contact first name and the left first character of the contact last name. So then we get those combined with concat, and then they become the initials, FA. Okay? So it's this kind of combination of this functional capability that gives you a lot of latitude in getting the output to look exactly like you want. Now I've got to say that these kinds of functions are pretty common in programming languages of all kinds. So those of you who've already worked with a character manipulation or string manipulation in a language like like a Java or Python or C#, this is going to look a lot more familiar to you than people who are new to programming. But get practicing at it, and practice makes perfect, right? Now, dates are pretty important things, and they get a lot of respect from SQL. There is a date type. There are typically several date types in any implementation of SQL. And a lot of times what we don't want to see its internal format. In fact, there's one of the types that's a date and time type. So what if you want to only see the date type and not the date and the time? So this date format is a function that allows us to get a character string representation of a column that's in that has a data type date, and just see it the way that we would like. So in the example that we have here, as you can see, you use the name of the function date_format, and then in the parens we've got the arguments or parameters depending upon how you want to call them. And so the first one is the date. So again, we want to give it some kind of date. So it's either going to be the name of a column, it could be a literal character string, something that's going to qualify as a date, and then we have a format string. So this format string here, you have to learn how to code them. So percent small m slash percent small d slash percent small y is going to give us month, month, day, day, year, year, separated by slashes. Percent E hyphen percent B hyphen percent capital Y is going to give us DD slash mun slash YYYY, as you can see here. Now, we've got more details in the textbook about how to author these format strings. And of course, if you look up the documentation for MySQL or SQL more generally, you'll see a lot more data on how to come up with these character strings to get the data in just the format that you want. Okay? Rounding. Rounding's pretty important stuff. Now, one of the nice things about relational databases and SQL is that there is a data type that's decimal. So, so you can have a number with a fixed number of decimal places. It's very friendly to dollars and cents. Okay? So normally, if you're storing a number as dollars and cents, and then you want to list it out, well, you don't need to round it at all. However, if you start doing a division of a dollars and cents number, or you start doing multiplication times some kind of a fractional amount, you'll get more than two decimal places, so you'll get fractional pennies. So it's not uncommon for us to want to round in some way. Okay? So we have a round function, and as you can see here, we say round invoice total. So we don't have any second argument. So if we don't have a second argument, that means round to round off the fractional amounts. Okay, turn it into an integer. Okay, so we can see nearest dollar, we've dropped all the cents. And then here we say invoice total, comma, there's another argument. One, we're saying one decimal place. And then we call that the nearest dime. Okay, now typically, we're only going to want to do that when we've done some math and we've left ourselves with fractional sense. Okay, this is probably not the best example of why we would want to do this. Okay, there are times when we want to round to whole dollars. We just don't want to bother ourselves with, say, cents. Okay, not a lot of times when you want to round to the nearest dime. Okay, now slide number 27 for me is kind of goofy because it is possible to, let's say we want to test a calculation, okay? So we don't really want to get anything from the database at all. We just want to have this calculation, 1,000 times 1 plus 0.1 as 10% more than 1,000. It's possible to just list in the column list, to just have an expression, and what we got is we didn't really use any columns out of any table, and yet this is a valid query that you might want to use if you were trying to test out some kind of calculation. It's not something I do all the time, but perhaps it appeals to you. Here's a statement on slide number 28 that tests a concat function. Okay, and again, this isn't something I do, but I know that other people do it, or it wouldn't be in the textbook. Here's a statement that tests the date function. So it turns out that current date is an sort of internal variable, okay, that takes on the current date and time. And so if you wanted to test a date format, you could use the expression current date. So this is a special name that has the value of the current date. Here is a statement that tests round. Okay. Here's a select statement that returns all rows. Okay. And why does it return all rows? It does because we don't have a where clause. Okay. So the default, when we don't specify where, is that we're going to get all the rows. Okay. What if we wanted to eliminate duplicate rows? Well, we can say select distinct. If we put the distinct in, then it will eliminate duplicates. Now, if we are listing all of the fields in a table, okay, that's going to include the primary key. The primary key is always unique. So if we were if we were listing all of the columns, then we wouldn't have to eliminate duplicates, because there are no duplicates, because the primary key would be different on every row. As soon as we have a subset of the columns, though, it's possible for there to be duplicates. And there are a lot of times when we're trying to come up with, say, a list, we don't want duplicate entries. So selecting distinct is a really good way to do that. So if we back up, let's to slide 31, where we said select vendor city, vendor state, and we could have said select all vendor city, vendor state, ALL. That's the default. Okay, so that's the way that's why we're not saying select all. You can see that there are two entries for Anaheim, California, 3 entries for Boston, Mass. Okay. On the next one, where we entered distinct, 1 entry for Anaheim, California, 1 entry for Boston, Mass. Okay, so this is a pretty common use case. All right. It's only going to make sense when you are asking for less than all of the columns, because again, if you ask for all of the columns with an asterisk, they're always distinct from each other, because there's always one field that's different, the primary key. Okay. The syntax of the where clause with comparison operators. So the where clause is going to do a lot of heavy lifting for us, because again, we really don't want to build queries that bring back a lot of data that we can kind of sift through. Why do the work when you can have the server do the work? So we're going to want to come up with an expression that brings back just the answer that we want. Okay, so we're going to want to do some things like comparisons. So in where clauses, we have comparison operators. If we want 2 things to be equal, we use a single equal sign. I just want to compare this with more modern programming languages like, say, Java, where we use equal equal. Okay. SQL is much older than Java, and it comes from the days where people still had their head on their shoulders. So If we want to test for equal, we do it with a single equal sign. Less than and greater than, pretty straightforward. Less than and equal, greater than and equal, pretty straightforward. There are two ways to say not equal. You can either use less than, greater than, or you can use the exclamation point, which we call the bang. You can so we can use bang equals red, bang equal or not equal. Okay, so with these things in our bag of tricks, we can have some interesting where clauses. So we have vendor state equals the abbreviation for Iowa. Invoices with a balance due, where invoice total minus payment total minus credit total greater than 0. Why don't we need parentheses around this? Well, because it's just subtraction and we have the commutative rule, we don't care what order we do them in. And what happens is we just do them from left to right. Or this one says where invoice total is greater than payment total plus credit total. So there are two ways to do that. Vendor names from A to L. So we say vendor name less than the single character M. Invoices on or before a specified date, less than or equal, and then we have the date. This particular way of expressing the date, where you have year, dash, month, dash, day, is a special format that's part of an ISO standard, and it makes it very easy to compare dates. So you see, you'll be using that format a lot. And here's one, on or after a specified date. Invoices with credits that don't equal 0. Two variations. Okay, so there's all kinds of things that you can do in the where clause. And again, you don't want to bring back even one more row than you need. You want the answer set to be the answer, and you want all the thinking and all the hard work and searching around and noodling in the data to be done by the server. Now you can use logical expressions in the where clause, and we do them all the times. And logical expressions include the operators for and, or, and not. Okay? So let's just look at this. The first example here uses the and, where vendor state equals New Jersey, or NJ, and vendor city equals Springfield. So those both have to be true for the entire expression to be true. That's how ands work. The or, where vendor state equal New Jersey or vendor city equals Pittsburgh, for that to be true, either one or the other have to be true, or both could be true. So Springfield, New Jersey would qualify. Pittsburgh, Pennsylvania would qualify too. Pittsburgh, New Jersey would qualify as well. And then the not operator, where not vendor equals CA. So everything that's not vendor state equal California. Okay, so there's a lot of expressiveness here to get exactly what you want. Okay, and generally speaking, things work about the way you think they would. You've got to test out and make sure that they're working exactly the way they think you would. Here's examples of where clause that use logical operators, a couple more. The not operator in a complex search. So we're not invoice total greater than or equal to 5,000, or not invoice date less than or equal to that. The same condition rephrased to eliminate the not operator, where invoice total is less than 5,000 and invoice date is less than or equal to. Okay, so what's the lesson here? Well, there are two lessons. Lesson one is that knots can be confusing, and they're to be avoided when you can avoid them. And the other thing is a rule from symbolic logic called De Morgan's law. And if you want to take a whole expression that includes an and or includes an or, and you want to negate it, okay, there's an interesting way to convert it. So if you want to take the expression A and B and negate it, it turns into not A or not B. So it turns into the other operator. If you want to take the expression A or B and negate the whole expression, it turns into not A and not B. So I don't think we have a slide for De Morgan's law here, but this is an example of having used De Morgan's law to simplify the first query into the second. 37, we have a compound condition without the parentheses. Here's where I just get kind of nuts. Okay? The order of precedence for compounds is not before and before or. And here's where I really want to break legs, because this is a thing that I don't even remember. All right? So you had better be using the parentheses if you're on my team. The same compound condition with parentheses. This is the way that we want to go. Okay? Then you can be on my team, and I won't hurt you. I like this in thing. Okay? Now, we have a subquery, which is kind of fancy schmancy, and we'll talk about that last. We can say that we want something to be in a list or not in a list. Okay? So the first example here, where terms ID in 1, 3, 4. Okay? So if it's 1 or 3 or 4, it's going to pass. We're going to get that row. If it were 2, it would not pass. Okay, and then the next one, where vendor state not in CANVOR. Okay, so if it were in CA, the row's not going to pass. If it were in IL for Illinois or WI for Wisconsin, it would pass. And then we're eventually going to learn how we can say where a column value is in, and then instead of having a fixed list, we can build a list from a query, and that's called a subquery. That's a special skill that we're going to be learning, in a handful of chapters. Okay. Between. Okay, so if we want it to be between literal values, like we're invoice date between one date and the other date, that's how we say that. Or we could say not between. We could have a between phrase with a test expression coded as a calculated value. We could have a between phrase with upper and lower limits. Okay? There's all kinds of possibilities. There is a thing called a like phrase. So we, especially when we're trying to look for characters, okay, we can use wildcard symbols like the percent sign, or we can use underscores, which become a kind of a wildcard just for that position. So let's look at some examples here. So the first one says we're vendor city like, and then we have the string SAN percent. So any character string that begins with SAN. Okay? Or we have where vendor name like compu, and then we have the underscore percent. So anything that begins with the compu some letter, any letter, ER, and then any more letters afterwards. So CompuServe and Computer World both qualify. Two old-time players, actually. There's also support these days, and very nicely so, for regular expressions. Regular expressions are a character matching meta language that were introduced as part of the Unix operating system back in the 60s and have become very popular across the board in just about every programming language. So you come up with an expression called a regular expression from these meta characters, and you have to learn how to do them. The O'Reilly book that's kind of the pocket guide is about 100 pages long. The O'Reilly book that has all the details in it is about 400 pages long. Easy regular expressions are pretty easy to do, and you can get some really arcane ones. There are a couple of good places to go on the net to learn about regular expressions. But here are some examples. So where vendor city regexp and then the character string that we're matching is this SA. So we're saying that if there is an SA anywhere in the string that we're trying to match, that is going to work. So wherever the SA is, that's going to work. Now the next thing we say vendor city regexp, and then we have a caret sign, a circumflex in the beginning. So this circumflex says what comes after has to be at the very beginning of the string. So this says starting with SA. So that's only going to match Santa Ana and Sacramento. And in the third example, the meta character $, when used at the end of a string, says that these characters have to come at the end of the string. So NA $ says ends with NA. So this would match Gardena, Pasadena, Santa Ana. And in terms of regular expressions, again, there's some good places to go, but let's just there's a cool website where regular expressions.info is the one I'm thinking of. And here's a whole tutorial on regular expressions. Really cool stuff. So it's definitely something, if this is the first time you're seeing it, that you're going to want to put a little bit of time into. And again, this is one of the 3 O'Reilly books on this. There are 3, I guess. So there's the pocket guide, there's the cookbook, and then there's the one that has all the details. So and they're all 3 good books. But this is free. A lot to be said for free. Would you agree? Okay, let's close our way out of that. And let's see what else we got. So in example 4, we say RS, and then the pipe, this symbol means OR. So matches RS or SN anywhere in the string. Example 5 matches n plus either c or v, so it would match nc or nv, but not nj or ny. Last one, 6, n, and then in brackets a through j, it would match NA through NJ, but not NV or NY because they're not in that range, A through J. So a very, very flexible way to do things. Here's another one. So this is example 7, a dummy and then EO, so either E or O and N, so it would match Damien or Damian. That's nice. So then we have example 8. Starts with A through Z and then has A, E, I, O, or U, N in the end. So starts with A through Z, so it started with a B, an M, and an O, and then one ends in ON, one ends in AN, one ends in IN. Okay, now that's pretty obscure. Okay, now null. We can say that we want one of the column values to be null, and this is very important. What does null mean in a relational database? Well, it typically means that we have not provided a value, okay? And it could mean a couple of things. It could mean we were too lazy to put a value in. It could mean that there is no value for that. It doesn't apply. It could mean that there is a value, but we don't know what it is. So one of the things you can specify for a column when you design your database is not null. And you see a lot of people trying to control the situations in which the users can avoid specifying a value for a field, okay? When you have a really tight design, typically null has a rational meaning, like this event hasn't happened yet, okay? So here, I guess we have invoice ID, invoice total, where, and I don't think this answer set really goes with the query up here, but when you have an invoice total equal null, maybe the invoice hasn't been issued yet. I'm not sure. Does it have a special meaning? I don't know. So here's a statement that selects rows that have 0 values, where invoice total equals 0. Here's a statement where they're non-zero. Now the good thing about 0 and non-zero is that these are real values, whereas null is sort of a non-value. It's kind of a, did not participate. Here's a statement that returns null values, where invoice total is null, or the non-null one, where invoice total is not null. Now I'm going to tell you, and I'm pretty sure that there's an exercise on this. Don't compare null as a value. So invoice total is null is the way to express it. Invoice total equal null is not going to get you what you want. Invoice total is not null will get you what you want. Invoice total not equal null will not get you what you want. So you need to use is null and is not null to get you what you really intend in those situations. This is a common error. The expanded syntax of the order by clause. So we've seen the order by clause, right? So how can we fancy it up? Well, I've already told you that you can ask for either ascending order or descending order. Asking for ascending order is kind of redundant because that's the default, and that's how we normally think of sorting. But DESC is how we ask for descending. So if we want descending, we put the name of the column or the expression, and then DESC. We can combine these. So we can say we want to sort on A, comma B, comma C. And when you know about sorting, you'll know that it's going to compare on A, okay? And if they're different, then that's the end of it. It sorts based upon the difference. If the A column's equal, then it'll look on the B. And if they're equal to, then it's going to move on and look at C. If not, if the B's are different, it's going to sort on that. So you only consider the second or third or fourth column if all columns have been equal so far. And that's just how sort fields work. The default sequence for an ascending sort: null values, then special characters, then numbers, then letters. Some people are surprised at the way capital letters sort as compared to lowercase. So it's interesting to look at the sort order and kind of experience it yourself. Null values will appear first in the sort sequence even if you're using descending. So again, null values are ugly. All right. So there's a lot of design advice would say try to steer clear of null values unless you really want them to express something like this event hasn't happened yet, okay, which has a real meaning. Okay, has it happened or not? You can look and you can see, is there a value there or is it null? Okay, apart from that, null values are just a lot of heartache. In order by clause, it sorts by one column in a descending sequence. So order by vendor name desk. In order by clause, it sorts by three columns: by vendor state, vendor city, vendor name, all ascending because that's the default. And again, if the vendor state, if the vendor states are different, it stops there. If the vendor states are the same, then it goes to vendor city. If the vendor cities are also the same, then it goes to vendor name. And order by clause, it uses an alias. Okay, so we can actually order by one of the columns that we created up in the select clause. Okay, so up in the select, we created a column and we gave it this alias called address. That is okay to use in the order by clause. It's not okay to use everywhere, but it is okay to use in the order by clause. Here's one that uses an expression. Okay, so we want to take two columns and concat them and use that for sorting it. Here's one that uses column positions. Now, this is something that I think you should know, but it's something that you shouldn't practice because it's not a good practice. The columns in a table are defined in a particular order. Okay, and when we learn how to define columns, I think in chapter 10, you'll see how to do that. Okay, so in the order by, you can say the number of the column. Now, over time, as you maintain your database, you may add columns. Well, if in fact you've used the names of the column in the order by clause, you're not going to break the ordering. But if you use numbers and you have added a column towards the beginning of the table, then you're going to screw up the order bys. So you can do this, and I want you to understand it if you have to maintain it, but it's not a good coding practice. And here's the limit clause. So you can have limit, and you can have offset and row count. So a statement that begins with the first row just says limit 5. Okay? And this one says limit 2, 3. So 2 says skip over 2 and then take 3. Now this is the kind of thing that you use when you're trying to send back multiple pages of things. So let's say you're creating a web app and somebody says they want the next page. Okay? Well, you want to skip over, if you just did the third page and you're going to the fourth, then you want to skip over 3 pages worth of rows and get the next however many you want to display. Let's say we're displaying 20 lines to a page. Okay, so we would want to, if there are 20 lines to a page and we just did the third and we're asking for the fourth, we want to say something like limit 60, 20. So we'd skip the first 60, we'd start with the 61st, and then if there were 20 altogether left, we would get all of them. So that's the typical use case for this kind of syntax. And here's one, limit 100, 1000. So we're going to skip the first 100 and then we're going to take 1,000. This might be useful if we're working with the editor function in MySQL Workbench. But apart from that, this is kind of a goofy set of requirements that I'm not going to burden you with. So that's it for the lecture. And I am going to say bye until next time. Bye-bye.